Okay, we're continuing with integration by parts. Another example of recursive, which is where you're taking an antiderivative, and what you're ending up with is going to be basically resembling, or part of it is going to resemble what you started with. So this is integral of sine to power n of x dx, or it could be cosine to power n of x dx. And what you basically thinking about is that, well, do we have anything, or do we already know some methods? And yes, you do. You for depending on what it is, there are multiple methods of solving this. Integrals related to basically for many of these integrals, there are methods that are related to trick identities and that sort of things. And so basically there are other methods, not for every one of them, and this is a generalized method that works for all of them. A lot of times we're going to tell you to use the other methods, but knowing this formula is also useful. So shooting in the dark, I'm going to choose dv to be sine of x dx, because I know how to antiderivative that, and u to be whatever is left over, which is sine of x to power n divided by sine of x. That's one less of the, and so I know how to antiderivative that. Again, n could be any value bigger than 1, any whole number bigger than 1, and so basically that's why I'm going with this. And so over here, wait, that should not be there, that's u. So when I'm taking antiderivative, taking derivative of u, I will end up with n minus 1 times sine to power 1 less than negative n minus 1, so n minus 2x, then derivative of sine of x, which is cosine of x dx. And then over here I will have antiderivative of sine of x, which is negative cosine of x to be v. Now let's write this up, and I'm writing it up this times that, which is negative cosine of x times sine to power n minus 1 of x, then minus the integral of this times that, and there's a negative sign in here, so I put a positive in here, and I will get cosine squared, so n minus 1 cosine squared of x sine to power n minus 2 of x dx. Okay, so far so good, except that it's still messy over here, and I have cosine squared sine to power n minus 2 of x, cosine squared of x times sine to n minus 2. So what do I do at this point? At this point, I start hoping to do the recursive thing. That's again over here. This is a. I want to create a as a term on the other side. What do I have? I have cosine squared and sine to power n minus 2 functions, basically. What if I use, for cosine squared, what if I use 1 minus sine squared of x instead of cosine squared of x? Then I will have that term reappear. So let's write everything up again. If I switch that, I get negative cosine of x sine to power n minus 1 of x plus 1 times this, everything else, which is, let's take the n minus 1 out. And so it would be sine to power n minus 2 of x dx. And then I will have negative n minus 1 sine to power 2 times sine to power n minus 2. These are the two functions, and I will get sine to power n of x dx. Okay, I went back to what I started with right here, a and a in here. So if I solve for a, so again, a is equal to negative cosine of x sine to power n minus 1 of x plus n minus 1 integral sine to power n minus 2 of x dx minus n minus 1a. I can solve for a by basically isolating a and taking it to the other side. It would be n minus 1 times a plus a. So it would be n plus 1 times a is equal to whatever else you have, minus cosine of x sine n minus 1 of x plus n minus 1 integral of sine to power n minus 2 of x dx, right? Okay. Everything is okay. Now, that did not solve my problem a whole lot. I still have that integral sitting right there. But it made it a little easier because the exponent decreased by 2 basically. And so when the exponent decreased by 2, what I can do, and so for, let's say, for n bigger than 1, so if bigger than 1, n minus 2 is a little smaller, I can recursively find this integral using the same method and same formula, and decrease the degree by 2 and then decrease the degree by 2 again until I either hit 0, so sine to power 0 of x, or I hit 1, which is sine to power 1 of x, because we're decreasing by 2, and any n mod 2 is going to be 0 or 1 basically at some point. What you left with eventually will be either 0 or 1. So if you do it a few times, you end up with 0 or 1. Now, all that said, let's rewrite the entire thing because I haven't solved for a yet. What was a? Let's put the a as it is. So the formula becomes sine to power n of x dx, and I will have a, that was this, 1 over n plus 1 times this entire thing, negative cosine of x sine n minus 1 of x plus n minus 1 integral sine n minus 2 of x dx. And again, so you continue using this formula until you end up with something that you can take the antiderivative on that side basically. In a worksheet, you will see all these different methods again. Generally, a lot of these integrals are not of higher powers and can be solved with basically a trick or two. And so you sometimes when they're higher power, it's a good idea, or for specific powers, it's a good idea to memorize this formula or know how to drive it out, basically.